solving logs using condensing properties. So these equations require us to use our log properties, the product property, the quotient property, and the power property. Let's do a quick refresher. Our product property says the log of any base b of m times n can be rewritten as the log base b of m plus the log base b of n. This we're going to use backwards, so we're going to be going, if there's addition, we're going to be writing as multiplication. Our quotient property says if I have the log base b of m divided by n, that's the log b of m minus the log b of n. And again, if we see subtraction, so we're going to be going backwards, we're going to be write it as division. And then our power property says log base b of m to the n is the same as n times log base b of m. And we'll be going backwards, writing our coefficients as exponents. So in the first problem, we have log base 6 of x plus log base 6 of 2x equals log base 6 of 32. My addition here tells me I'm going to use my product property, so I'm going to rewrite it as a product of x and 2x with one log. Log base 6 of x times 2x equals log base 6 of 32. X times 2x is 2x squared. And since we have log base 6 equal to a log base 6, we can set our logs equal to each other by using the one-to-one property. So 2x squared equals 32, and I can divide by 2. X squared equals 16. X equals plus or minus 4. And then we want to look, we got two answers, so we want to look back. If I plug in positive 4, are all of my logs positive? So the answer is yes. And if I plug in negative 4, are all my logs positive? No. If I plug in negative 4, both of these logs are negative, and so negative 4 is extraneous. My only answer is x equals positive 4. In the next problem, ln x minus 5 is equal to ln of 3 plus 6. Now the first thing we have to do is move things around a little bit, because that 6 out there can't be combined because it doesn't have a log on it. So this doesn't have a log, so your natural log, I can't combine it. So what I want to do is move my ln 3 to the other side. And I get ln of x minus 5 minus ln 3 equals 6. And then I can use my quotient property and write this as a quotient. X minus 5 over 3 equals 6. And now I need to either exponentiate or rewrite it as an exponent. I'm going to choose to rewrite it as an exponent. So this is log base e. So I'm going to bring the ln, becomes e. What it's equal to becomes my exponent. And what's inside the log goes on this side of the equal sign. X minus 5 over 3. And then I can solve it. So I have x minus 5 divided by 3 equals e to the 6th power. I'm going to times by 3 to get rid of the denominator. So x minus 5 equals 3e to the 6th. And then I'll add 5. And x equals 3e to the 6th plus 5. We can plug that into a calculator and get a decimal approximation if you have one. And I got x is approximately 1205.286. Okay, and our last problem is the 1/2, the log base 3 of x equals negative 2. The first thing I can do, you could actually solve this two ways. You can make it the exponent, so you can make it the log base 3 of x to the 1/2 power equals negative 2. we could solve it that way. Let's do that here. I'll rewrite this as a log. 3 to the negative 2 equals x to the 1/2 power. Remember that the 1/2 power is really just the square root of x, equals 1/9. And then I square both sides to solve it. So I get x equals 1/81. Now the other way to do it is to multiply by 2 to get rid of the 1/2 out front. So if I have 1/2 log 3 of x equals -2, I can times by 2, and then the log 3 of x equals -4, and then rewrite it, x equals 3 to the -4th, which is again 1/81. Of course, this method did not use the properties.